So all right. So yeah, we will continue. We're almost done with the first chapter of our book on the algebra essentials. Okay. And so we're ending the discussion on polynomials, and then we'll move on to the next chapter, and that's now talking about equations and inequalities, but we will begin with the discussion on the rectangular Cartesian coordinate system. So we'll just continue from where we ended last meeting, where we learned about simplifying rational expressions. And simplifying rational expressions would really require a good understanding of our factoring of polynomials, because that's the way to simplify. And even as we move on to multiplication of polynomials or adding and subtracting polynomials, we'll be needing a good understanding of factoring. So we'll do a lot of practice of factoring in our discussion on multiplying and adding as well as subtracting polynomials. So let me just share this screen. Okay. So yeah, so we did simplifying in our discussion the last topic we considered last meeting. So just the same, even as you multiply rational expressions, you will also be doing a lot of simplifying. All right. And so I have this example. So we're multiplying x squared plus 4x minus 5 over 4x minus 4 times 2x plus 4 over x plus 5. So you know how it is when you multiply fractions. We usually multiply the numerator times the numerator and the denominator times the denominator. But then with this, okay, because in the end, we will do simplifying, so it is better to begin by factoring. So just to remind us of factoring, we'll have some examples later on, but I just would want this x squared plus 4x minus 5. Yeah, this one is, of course, a polynomial with a leading coefficient equal to 1. And therefore, that's kind of, looking at the factors of -5, such that the sum of those two factors would be 4. So you know that the factors would be x plus 5 times x minus 1, because 5 times minus 1 is -5, and 5 minus 1 is 4. Yeah. The one at the bottom of the first rational expression, 4x minus 4, just dealing with, let me use my highlighter, okay? We just look at, okay, 4 is the common factor, so you'll now have 4 times x minus 1 times 2 times, okay, again, the 2x plus 4, your common factor is the 2, and therefore that's 2 times x plus 2. And the x plus 5, we don't need to factor anymore. Well, the book here, actually, you can just immediately do the simplifying by taking out or canceling out factors, but just for, following the rules that indeed, whenever we do multiplication, we just multiply the numerators, multiply the denominators, and write as one fraction, so that we now would say we are able to do canceling out. And so as after putting them in one fraction, then we simplify by canceling the common factors. Okay. And so that's we have, all right, we'll be doing that. So we simplify or cancel common factors. So we find that x minus 1 and x minus 1 at the bottom. All right. So cancel those out. And x minus 1, and therefore, then the x plus 5 and x plus 5 can also cancel. So that one, x minus 5, x minus 1, and x plus 5 and x plus 5. So what remains? And of course, you have a 2 and a 4 down there. And so we can cancel out the 2, but there's a 2 remaining when we divide 4 by 2. And so our final answer will now be x plus 2 over 2.
I would have left it.
Okay, so let me once again just erase and then, okay, let's do that again. So x plus 5, x plus 5, x minus 1, x minus 1, 2 and 4 has a common factor 2. And so we now have x plus 2 over 2. So that's how it is.
Can I ask a question?
Yes.
With that, how do we know, because we canceled out the 2 and the 4, but when you bring it to x plus 2 over 2, how do we know that we can't cancel out the 2 2's?
Okay. The reason is because you now have x plus 2 after this one, x plus 2 over 2. Is that what you're saying?
Yes.
Okay. This means that you are not, that can only cancel if you have a 2x times over 2. But this one is x plus 2 over 2. In other words, your 2 is the denominator of, it's the same as x of 2 over 2. But then you don't need to do that anymore because we just want that's a simple, x plus 2 over 2 means x over 2 plus 2 over 2. So you actually are supposed to be, that should be x over 2 plus 1. But we want our final answer to be just one fraction, and that's the reason why we end it there. So you cannot
So
cancel 2 and 2.
if it's a multiple, then like 2x over 2, then you can cancel it out.
Yes,
But if it's
yes, that one can be canceled. But when it's
okay.
addition, you cannot cancel anymore. So it's only in multiplication that you are able to do cancellation, because if it's multiplied, that means that 2x divided by 2. And so 2x divided by 2 is equal to x. But x plus 2 over 2, it is actually supposed to be, if you want to separate that as fractions, it is x over 2 plus 2 over 2. But so you just remain with that because we want our answer to be one fraction rather than a separate like this. So actually these two are the same. They are equal.
Okay, that makes sense. Thank
Ah,
you.
okay, yes, you're most welcome. Okay, so that's how it is with multiplying rational expressions. Let us try some exercises here. Okay. So I have x squared minus 4x minus 5 over 3x plus 18 times x plus 6. So as I was saying a while ago, let me go back here. For some of you, it may not be necessary to do number 2, that number 2 process, okay? Yeah, because you can immediately do cancellation here, right? So for us, it's just that I just, in case you are following what the book is saying, but from there, immediately you can cancel x plus 5, and x plus 5, x minus 1, and x minus 1, and then 2 and 4, and go direct to your answer of x plus 2 over 2. So I won't require, if you feel like it's, I just do that there and immediately go to number 3, that would be okay, right? So let's now proceed.
Okay. What if you leave it as x plus 2 over 2?
That's the final
What was
answer,
it?
actually. Yeah, this one. This is the answer. X plus 2
Oh,
over 2. I
okay.
was just explaining that if you want to divide, it should have been written as x plus over 2 plus 1 because of that question. But the final answer is now x plus 2 over 2 because we want our final answer to be one fraction as of the moment rather than separating them.
Okay.
Is
Thank
that
you.
okay? Yeah, we will, of course, be talking about adding fractions later on. But as of the moment, if I add x plus 2, x over 2 plus 1, that can be added as x plus 2 over 2. All right. So let's proceed to this. As I was saying, number 2 may be eliminated. Just proceed by simplifying and canceling common factors. All right. So please practice now your factoring. Then we'll discuss. Okay. All right. So for letter A, the factors. Okay. So the factor for the numerator, you now have x squared minus 4x minus 5. Factors are x
5
X,
and
X minus 5, X plus
minus
1.
5. Yes. X plus 1. Okay.
1.
Mm-hmm. And then I think the denominator of that, there's a common factor. This is 3. Then that is x plus 6, right?
Yes.
So I think your
Mhm.
x plus 6 is already, there's no need to factor that. That's already just 1 and x plus 6. And from there, you can immediately cancel, right? So you can
Yeah.
put now the final answer, and our final answer will be,
X plus 1 over 3.
okay, very good. Yes. So we cancel x minus 5. We cancel x plus 6. So x plus 1 over 3. Good. All right, let's do letter B. You can use your factoring by grouping, or if you think you
Mhm.
are able to do factoring by just doing trial and error, that would also be fine. For the 2x squared plus x minus 6. Don't talk. Mhm. Okay. So what are the factors of 2x squared plus x minus 6?
2x minus 3x plus 2. Oh, if that's right. 2x minus 3x plus 2.
2x minus 3x plus 2. Everyone got that?
Almost.
Almost. That's okay. Yeah, because if you are doing factoring by grouping so that you don't do a lot of trial and error, yeah, actually, as I was saying, you can, if ever you don't want to do, you just want to go direct, you know that 2x squared, the factors are 2x and x. And you know the factors of minus 6 is either a minus 3 or times 2. It can be 6 and 1, it can be 2 and 3. But you just have to think of factors that when you add, will give you a 1. So 1 is a minus, the other is a plus. So that 2x minus 3x plus 2, if you just want to do that directly, but otherwise, you can use your factoring by grouping. Yeah. So is the 2x minus 3x plus 2 okay? You have done that, or we want to still do factoring by grouping? You can do it. So you know that 2 times negative 6 is minus 12. You remember that. You multiply AC. And then you think of factors of minus 12 such that when you add, it will be equal to 1. And I think you know that will now be a 4 and a minus 3. Yeah, and then you can, as we have learned last time, we said 2x squared, then you have plus 4x minus 3x minus 6. And then put the common, put this together. So common there is 2x, and you have now x plus 2. Minus 3 is common, then that is x plus 2. So that x plus 2 will now be 2x minus 3. But it can be interchanged because they are commutative. So it's 2x minus 3 times x plus 2. Is it okay? Then, of course, you know the factors of x squared minus 1. That's now what we call the difference of two squares. And so the factors are,
X minus 1, X minus 2.
okay, x, let me just now erase this part so that I can do writing. So you know that so I just want to show how to do factoring by grouping. Of course, factoring by grouping is, as I already said, it's more systematic than just doing some trial and error. But if you are already into the point where you can do trial and error, then that would be fine. So now we say over x minus 1, x plus 1. What are the factors of x squared plus 2x plus 1? What kind of trinomial is this? X squared plus 2x plus 1? Is that a perfect square trinomial?
Yes.
Yes. All right. So that the factors will now be x plus 1 squared, but you can just separate that. X plus 1 times x plus 1. Or x plus 1 squared. And you know that the factors of x squared minus 4 is x plus 2. The plus can begin, or x minus 2. It's just the same. Yeah. That again is a difference of squares. So it doesn't matter whether we begin with minus or a plus, because that one would just still be the same. And so canceling Common factors, what will be our final answer?
Two 2x minus 3
Okay.
plus 1 over x minus 1 times x minus 2. That's what is left. I'm not sure if we
All
should
right.
simplify.
So you factor, there's an x plus 2 here that will be factored, that will be canceled. And one of the x plus 1. Okay. Yeah. So yes. So the x plus 1 and one of the x plus 1. So you are remained with 2x minus 3 and x plus 1 over x minus 1, x minus 2. You stay that way, but otherwise, yeah, if you want to practice, but for me, that one would just be the final answer, already in factored form. So 2x minus 3 times x plus 1, because you need to multiply the numerators and the numerators, denominators, and denominator. Denominator and denominator. Now, for the sake of practicing your multiplying your polynomials like what you did in your homework 3, then you can just do your multiplication just for practice. But I would want the answer to be to leave your answer as in the factored form. So that's it. So 2x minus 3 times x plus 1. Okay, anyway, just practicing our multiplying polynomials. If in case we want to multiply, what is 2x minus 3 times x plus 1 for the practice? You remember, okay? So that will now be 2x times x gives you 2x squared. I just want to practice our multiplying the polynomials. Then what will be the middle term?
Minus x.
Minus x, yes. Minus 3, right? Okay. Yeah. So 2x minus 3x is minus x. Then 3 times negative 3 times 1. All right. How about the x minus 2 times x minus 2? Can you just give me the answers directly? It's x squared
minus 3x
minus
plus
3x plus 2. Very good. All right. But as I was saying, I want the answers to be factored, not this one. Okay, I just want you to learn how to practice how it should be. So that's it. So you now have 2x minus 3 times x plus 1 over x minus 1 times x minus 2.
Yeah, this is factor.
The factored form. So once you are, if you, so it's important that the factoring is very clear, clearly understood, because those are the basis on simplifying in multiplying rational expressions. So, okay, can we proceed? Now, let's move on to dividing. It's still the same. Actually, the dividing will make use of the process of multiplying. So that's the reason why I just want to continue, because you will still get practice on multiplying while you divide rational expressions. So, I just want to emphasize that division is the inverse operation of multiplication, because if you multiply the product of 3 times 2 is 6, okay? And if you want to get the other factor, you just divide. So 6 minus 3 is 6 divided by 3 is 2. So that's why we call them inverses. And now there's this multiplicative inverse property that we learned when we were starting our discussion here in class, where we're saying that if you multiply a number by something and the product is equal to 1, okay, then we say that this value is a multiplicative inverse. In other words, if I multiply, if the number 2, if I multiply 2 by 1/2, the answer is 1. Therefore, 1/2 is the multiplicative inverse of 2. In some other terminology, we call it reciprocal. I hope you still remember that. All right, reciprocal. So the reciprocal is actually the multiplicative inverse of a certain number. That means you just switch. So if you have a 1/3, the reciprocal of 1/3 is 3 because 1/3 times 3 is equal to 1. So we will make use of this understanding in dividing in dividing rational expressions. So this is what I'm saying. N is the reciprocal of 1 over n. 1 over n is the reciprocal of n. So the understanding of reciprocal is very important. So whenever we divide fractions, the idea is we just multiply by the reciprocal, which means that you keep the first fraction. Like if I multiply a over b by c over d, I divide a over b divided by c over d. You keep the first fraction, a over b, change the division sign to multiplication, and flip the second fraction to write the reciprocal. So in other words, if we're dividing, we are actually following the rules of multiplication, except that the first thing you'll have to do is flip the second fraction. Flipping means finding the reciprocal of the second fraction. So a over b divided by c over d is the same as a over b times d over c. Because as I was saying, they are inverse operations. And so we are just multiplying by what we call the multiplicative inverse, which is the reciprocal. So with that understanding, so that's why I just want to continue with division, because we will be doing really multiplication. Okay. So just suppose I have 9x squared minus 16 divided by 3x squared plus 17x minus 28 divided by 3x squared minus 2x minus 8 over x squared plus 5x minus 14. All right. So what we will do is we rewrite the first rational expression and multiply by the reciprocal. So you notice here, I just copied 9x squared minus 16, 3x squared plus 17x minus 28. But then I flip. Okay, then this one will now become x squared plus 5x minus 14 over 3x squared minus 2x minus 8. So just the first step, flipping. After that, proceed with multiplication. So the way we were doing a while ago, all right, then we will have to factor the numerators and denominators. So what are the factors of 9x squared minus 16?
It's a square.
Yeah, that's difference of squares. Yes.
So it would be
3x minus 4.
Mm-hmm.
3x plus
3x
4.
plus 4. Yes. Good. All right. I'll show those later on. Now, how about 3x squared plus 17x minus 28? Yeah, you can now do your factoring by grouping. Maybe is that much easier. Although you can, you know what we can do is you can say 3x x, right? Those are the factors of 3x and x. And you ask yourself, what are the factors of 20 minus 28 such that when you add, oh no, that one will be so okay, that when, but better do the factoring by grouping. I think it's easier for you to do that, or a little bit more difficult. Just for practice, you're factoring by grouping. Yeah, because if I were the one, I would just deal with factors of 28 can be 7 and 4 And then I can 21. And then if I subtract, okay, so if I were the one to do that, I would say it can be, I put a 7 here and I can put a 4 here. That when I multiply this and this, I will get 17x. So that's positive. So I can put that as plus. I can put this as minus. Okay. So that because 3x times 7 is 21 minus 4 is 17. But you can do factoring by grouping if that is much easier for you to do.
4 and 7 are the right ones, right?
Huh?
I'm saying 4 and 7 are the right factors.
Yes, of 28. Of course, you can have 7 times 4. You can have 14 and 1 and 2. But you think of two factors. That's that when I put the values in here, I can get that. No, I'm using the one that is not factoring by grouping. I was only dealing with that as a direct factoring. You say the factors of 3x and 3x squared and is 3x and x. Now you ask yourself, what are the factors of minus 28? One of them should be a plus, the other is a minus. So there are choices. It's either 28 and 1, or 14 and 2, or 7 and 4. I chose 7 and 4 because if I multiply 7 times 3x using our FOIL and a 4 times x and I subtract, I will get 17. 21 minus 4. So that's why I decided to just put the 7 there and a 4 there. But otherwise, you can do factoring by grouping. But of course, to do that, you will have to multiply 3 times negative 28. Then think of factors that when you add, it will become 17. So any of these will do. If you think you are able to do direct factoring, then you can just do that. So let me repeat. 3x squared is 3x and x. You know that one is a plus, the other is a minus because this is negative 28. And then it's now a systematic trial and error. So let me try 7 and 4. So trying 7 and 4, if I put 7 here and I put minus 4 there, then I can see if I multiply the two terms, I will be able to get 17x. So 3x times 7 is 21. 4 times x is 4x. 21 minus 4x is 17. And you'll get the same answer if you do factoring by grouping. All right, so we are
Can
now
you
saying, yeah? Okay, now
can
how
I
about the x
know
squared plus 5x minus 14? What will be your factors? Yeah, the factors of
7
14 is 7 and 2, right?
Yes.
X 7x minus 2.
So x, yeah, so 7 minus 2 is 5x, correct. All right, so what will be the factors?
X plus 7 times x minus 2.
Okay, x plus 7 and x minus 2. Good. All right. How about the 3x squared minus 2x minus 8?
It will be 3x.
And
It should be
x,
plus.
okay, then it's just that when you, okay, so I'm putting it here without factoring by grouping as of the moment, all right? Then what are the factors of 8 that you will choose?
2. Minus
And
4
then,
plus
so it
2.
should be 3x minus 4, then x plus 2. And then,
Okay, so you use a 4 and 2, okay? 4 and 2. And then you ask yourself, where will I put a 4? Where will I put the 2? Okay, now you want the product of this and this to be equal to minus 2x. So you put a minus 4 here and 2 there, or the other way around. Okay, I'm just trying to, so if you want to do some trial and error, so in other words, if I do that, that cannot happen. So I think we need to do some switching, okay?
yeah,
All right.
minus 4.
We want a minus 2x.
We'll put minus for this side on the 3x and then
Okay,
plus.
so you put at -2 that at the side, okay? Yeah, so -2 and this is a 4, right? Because
Yes.
-6x plus 4x is -2x.
You
Yeah, all right. So there now. Okay. So we now say that the factors of 3x plus 4 of 9x squared minus 16 is 3x plus 4, 3x minus 4. The factors of 3x squared plus 17x minus 28 is 3x minus 4x plus 7. And then you said x squared plus 5x minus 14, which is correct, as x plus 7 and x minus 2. And then the factors of 3x squared minus 2x minus 8 is 3x plus 4 and x minus 2. And from there, you now can cancel common factors. So we'll cancel 3x minus 4, 3x minus 4. And then,
1. 3x
what
plus
else?
4.
3x plus 4 and 3x plus 4. What else?
X plus
X plus
x
7,
plus
x
7.
plus 7. X minus
2.
2, x minus 2. What's the final answer?
1.
Okay. All
1
right.
comes.
The final answer is
That's
it's nice, yeah.
Uh,
It's a cute problem. After all those
yeah,
things, then you get the answer to be positive one. Nice.
it's like playing a game.
You're eliminated.
It's the same as this one.
That's what I told you. Playing a game.
Yeah.
Now you get it.
Okay, let's try some exercises here. So again, you are exercising now, not only dividing, but also multiplying. And at the same time, you're factoring. All right, try letter A.
Ooh. Ooh.
I'm just giving
Oh.
some simple problems with the leading coefficient as 1. So you immediately do the rewriting so you don't get confused and immediately proceed to a multiplication operation.
x plus 3 over x minus 2
Mm-hmm.
Times x.
times, yeah, and x plus 1.
Okay.
With x minus 2, x plus 1, and that's what the
Yeah. So
Mhm.
you have two factors in the denominator, okay? Yeah.
x minus 2 and x plus 1.
Uh-huh.
It didn't cancel.
Yeah, proceed with letter B, then we will discuss after that. I'm just giving time to the rest to finish what they're doing for letter A.
I got it, but
And
For letter B?
yeah,
Okay, what's your letter B?
3x
3 times x
times
plus
x
3.
plus 3 over x plus 4.
Okay. So your answer for letter A is x plus 3 over x minus 2 times x plus 1.
Yes.
And then for letter B, it is 3 times x plus 3 over
Mm-hmm.
x plus 4.
X plus. Yes.
Did all of you get it?
Yeah. Well, I did.
Right? So that just because I'm recording, it's just good to show the answer. So the first thing you did was for letter A, you put x minus 4 over x squared minus 4. Then proceed to multiplication and switch.
Mm-hmm.
Okay, so that's the first step to do so that you don't get confused later on. Then factoring, you know that the factors of the denominator here is x plus 2, x minus 2. Okay, or x minus 2, x plus 2. That's not a problem. All right, then times. This one is x plus 3, x plus 2, right? Because 3 times 2 is 6, 3 plus 2 is 5. And for this, the factors are x minus 4, x plus 1. Because 4 times 1 is 4, minus 4 plus 1 is minus 3x. Okay? And then I think that's what you did now. You cancel the x plus 2. What remains is x plus 3 over x plus 2 times x plus 1. Okay, so after canceling, we are good. Okay, and of course, for the other one, which is flip immediately and then proceed to factoring. Okay, let me just erase so that I will not remove the answer. I wish I can just use, I'm there with you, so it's easy to erase the board. Okay, so just the same for letter B, you rewrite x squared plus 2x minus 3 over x squared plus 8x plus 16 multiply 3x plus 12 x minus 1. And you know the factors of x squared plus 2x minus 3 is now x plus 3 x minus 1, right? Because 3x minus x is 2 and 3 times negative. And this is what kind of polynomial is x squared plus 8x plus 16? We call it a perfect square trinomial, right? So it will now be x plus 4 times x plus 4 times common factor here is 3 x plus 4 x minus 1. So x plus 4 x plus 4 x minus 1 x minus 1. So what remains is 3 x plus 3, all right, over x plus 4. So any question here?
No.
So you notice that multiplying, dividing, okay, they are just procedures the same except for flipping the second rational expression in the division process. Can we now proceed? Now, yes, this last thing on rational expressions, adding and subtracting. So we should be reminded of how to add fractions. We only can add fractions if they have the same denominator. No. So, yeah, you cannot add fractions. You cannot combine fractions if their denominators are different. So many times whenever I consider this as a concept in math, I would say you need to have a common denominator to agree or to be together. Okay. So talking about, having maybe the same blood because you're brothers and sisters, but at the same time, you can also really be, you'll have good relationships if your common denominator is that you're believers of Jesus, you need to be having a common denominator. So just make them the common denominator and then you just add the numerator. Well, that one had been learned in your arithmetic classes. So that if I have 1/4 plus 2/4, I can add them immediately because the denominator is the same, which is a 4. Okay. And so what you just have to do is only add the numerator. Okay. So in other words, 1 plus 2 is equal to 3. But if your denominators are different, I think you remember this before, I have now 1/2 and 2/5. 2 and 5 are not the same. We want to make them the same by making sure that they will have the same multiple. And if ever 2 and 5, like 2 and 5, there are no other common factors, you know that the common denominator The denominator that can be divided by 2 and 5 would be 10. That is a 5 times 2. So we will make use of our multiplying by 1. So we multiply 1/2 by 5 over 5. And we multiply 2 over 5 by 2 and 2. So that 5 times 1 is a 5. This is 5 times 2 is 10. 2 times 2 is a 4. This is 5 times 2 is a 10. So the factors, the denominator is already the same, or the least common multiple. And so 5 times 1 is 5. 2 times 2 is 4. So 5 plus 4 is 9 over 10. So we are just remembering how to add fractions. And so what is important is you should know how to find the least common denominator or the least common multiple. I just want to tell you at the outset that in arithmetic, many times it's a little bit confusing because you're looking at so many multiples. One thing with rational expressions is you're dealing with factors. And so it's easy for you to be able to see which one is a common multiple or common denominator as we move on with some examples. But just to remind us of how to find the least common multiple, if I have a 12 and a 20, you ask yourself, what number can be divided by both 20 and 12? So I think this is what we will learn in our arithmetic class. You factor 12. It's 2 times 2 times 3. You factor 20. 2 times 2 times 2 times 5. All right? And then, you notice that 2 is common here. So you say 2 is one of the 2 is part of the multiple. 2 and 2 would be common. Copy it as a common factor. And then 3 and 3, and then 5 and 5. And so 2 times 2 times 3 times 5 is 60. 60 is the least common denominator or least common multiple, because when we divide 60 can be divided by 12, 60 can also be divided by 20. And that is already considered least, because if you divide 60 by 12, you get a 5, all right? If you divide 60 by 20, you get a 3. And there is no more common factor between a 5 and a 3. So I am just reminding ourselves with what we call as least common multiple. But you will find that it's a little easier in our rational expressions. Okay. So let me start with this. A very simple addition of 1 over x plus 2 plus 2 over x plus 3. Now, the fact that x plus 2 and x plus 3, they are totally different, there's nothing common between them, then we know that the product of x plus 2 and x plus 3 will already be your least common denominator. So what you will do is, to make sure that the denominator will be the same, we multiply 1 over x plus 2 by x plus 3 over x plus 3. You're actually just multiplying by 1, so you are not actually changing anything. And then you multiply 2 over x plus 3 by x plus 2 over x plus 2. And therefore, for the first expression here, 1 times x plus 3, of course, is x plus 3. And then the factor would be x plus 2 and x plus 2. This one would be now your common denominator. 2 times x plus 2 is 2 times x plus 2. And the common denominator is x plus 2 times x plus 2. Then we just add the numerators. So if I multiply this by 1 times x plus 3 is x plus 3. 2 times x plus 2 is 2x plus 4. So just add these denominators. Okay, so I will just, maybe it's better to show it. Okay. So here we're actually just saying this is the same as x plus 3 over x plus 2 times x plus 3 plus 2x plus 4, because 2 times x plus 2 is 2x plus 4, x plus 3 times x plus 2. They already have common denominator, and therefore you can just add the numerators as x plus 3 plus 2x plus 4, and adding them, x plus 2x is 3x, 3 plus 4 is 7, and then it's now the denominator would be common. So 1 over x plus 2 plus 2 over x plus 3 is equal to 3x plus 7 over x plus 2 times x plus 3. Now, some of you might want to if you already understand the concept of adding fractions or rational expression. Many times we may skip this part. Maybe you have done that previously. What you just did, you can just do this. All right. So I'm just putting in here. You know that the common factor is x plus 2 and x plus 3. All right. So actually, one way of doing it, skipping this part. I multiply this and that. Right?
Yes,
Mm.
yes.
So 1 times x plus 3 is x plus 3. No. I'm making only the long process to show you why it is so. All right? Plus 2 times x plus 2 is 2x plus 4. And then you now go directly to adding. Isn't that much easier? All right? But I just showed this because I want to show the reason why we are able to do that, because we are actually multiplying by a 1. X plus 3 over x plus 3 and x plus 2 over x plus. So you can just do directly, especially if your problem is as simple as like that, where the denominators have nothing in common and they are totally different, so that the least common denominator will be the product of the two. Okay. So that's how it is. The principle is put your fractions or your rational expressions have to have the same denominator, and having the same denominator, you can just add the numerators. Yeah, right. So similarly with this, it's subtracting. So subtracting will also be the same. Okay. So now just the same here. They are x plus 5, x minus 3. They are already different factors. So the common denominator is x plus 5 times x minus 3. So skipping this number 2 and 3, we can do that directly. Okay? So what do I do? Common would be x plus 5 and x minus 3, right? They are the common denominator. So I multiply, right? This one.
Yes.
Okay?
3
So it will now be 3 times
X
x
minus
minus 3 minus
then
1 times
X plus 5.
x plus 5. Okay, this is a 1. All right. Therefore, you now have 3x minus 9 minus x minus 5, right? I'm multiplying minus 1 times, this is a 1, huh? All right. Minus 5 times, minus 1 times x, minus 1 times 5 is minus 5 over x plus 5 times x minus 3. 3x minus x is 2x, okay? Minus 14, correct? Over x plus 5 times x minus 3. Now, we want our final answer to be completely factored. And that is the reason why I have this. Common of 2x minus 14 is 2. And so, factor out 2. Your final answer is 2 times x minus 7 over x plus 5 times x minus 3. So that's how to do. So it's the same as adding, except that, of course, you are having a minus in between rather than a plus. But the procedure would remain the same. Is that okay? Anyway, this one I am posting on our website, so you can just go back to that. All right. How about this? I will still be doing subtracting rational expressions. In this situation, I think you know that the first step, because these are now x squared plus 4x plus 4, x squared minus 4, it's totally different from the previous examples. These ones, it's necessary to begin by factoring the denominators. So whenever your problem is necessitates factoring the denominators, you'll first do the factoring before proceeding on to finding the least common denominator. So I now have x squared plus 4x plus 4. You know that that is a perfect square trinomial. And therefore, it's just x plus 2 times x plus 2 or x plus 2 squared. All right? Yeah. For x squared minus 4, the factors are x plus 2 and x minus 2. So therefore,
Yes.
your LCD would be, x plus 2 squared can already be divided by x plus 2. So between this, the least common is x plus 2 squared. And of course, x minus 2. That's the least common denominator. X plus 2 squared times x minus 2. And then, we multiply the expressions, as I was already saying. Okay, at this time, you multiply by the least common denominator. I mean, you multiply by something so that they will have the same least common denominator. Okay, in other words, if I have 6 over x plus 2 squared, for me to have the least common denominator x plus 2 squared, I multiply this fraction by x minus 2 and x minus 2. So that I'll get x plus 2 squared times x minus 2. For this fraction, 2 times x plus 2 over x minus 2, so that I can get an x plus 2 squared times x minus 2, I just multiply this by x plus 2 over x plus 2. Because if I do that, x plus 2 times x plus 2 is x plus 2 squared times x minus 2. So here, in other words, they now have the same denominator. And then you now proceed by multiplying, and you get 6 times x minus 2 over this minus 2 times x plus 2 over x plus 2 squared times x minus 2. And proceed with putting them together. So 6 times x minus 2 minus 2 times x plus 2, 6x minus 12 minus 2x minus 4, okay? With a common denominator, combining them, 6x minus 2x is 4x, minus 12 minus 4 is minus 16, and then finally, you need to have completely factored form. Common with 4 times x minus 16 is 4, and therefore you now have 4 times x minus 4 over x plus 2 squared times x minus 2. You can put that as x plus 2 times x plus 2. But it's better to write it as x plus 2 quantity squared. So, the same process, except that the first thing you'll have to do is you factor the denominators as it has been necessitated, because your denominators are not the factored form yet. Now, if you don't want to proceed with this number 2 here, that can also be done directly. What you will just do is, after factoring, I just want to show a more, after factoring, okay, here, you already have factored it out, right? So you put
Yes.
that under one, maybe for those who have done this, okay, let me just erase that. It's already know that. Okay. All right. So that from that part. Okay. Okay. So we consider this. The common now is x plus 2 squared. Oops, sorry. So small. X plus 2 squared, you already know this to be the least common denominator, and X minus 2. All right. So what you will just do is, I look at this section. Okay. So there is an X plus 2 squared there. Right. And so the one that is lacking is the X minus 2. So just like what you're doing for X times 2 minus 2 times X minus 2. So you just immediately say, I multiply this by 6 times X minus 2. Okay. Minus. For the X plus 2, X minus 2, I'm lacking with X plus 2 to have it as X plus 2 squared times X minus 2. So you can now have just minus 2 times X plus 2. So you are already coming directly to this part. Yes. But you can do it step by step so that you don't get confused. But that can also be done. So as I'm saying, whenever you do your work, if you don't do number 2, because you already know what to do, then that would be fine with me. I won't look at all the processes. Okay, so from here, you can already move directly to this part. All right, there. And so, get the answer. So for adding or subtracting, one thing is, if it's necessary to do factoring, then that would be fine. Otherwise, if not, then you can, okay, just proceed. All right. So let's try this one. Okay, I'll give you that as an exercise. I have now 1 over x squared minus 1 and 2 over x plus 1 squared. Factor as necessary, and then you find the LCD. I think that one is easy to... So what would be the LCD?
X plus 1 and X minus 1.
All right. But the other one has a square, x plus 1 squared. So in other words, yeah, it should be x plus 1 squared, because x plus 1 cannot be divided by x plus 1 squared. So it's the x plus 1 squared, and then the other factor of x squared minus 1, which is x minus 1, right? Yeah, because the factors of x squared minus 1 is x plus 1, x
And
minus
X minus
1. So the LCD between the x plus 1 squared and x plus 1 is x plus 1 squared. So you cannot just put x plus 1 because we want that factor to be divided by both. So x plus 1 squared can be divided by x plus 1 squared. X plus 1 squared can be divided by x plus 1. So you get the one that has the higher power, okay? So this is now
So
our
x
LCD. Yeah? Is that
so
clear?
x plus squared is the LCD.
Times x plus 1, times x minus 1. So if I have now x plus 1 times x minus 1 as the factors of this, and then of course this one is already factored as x plus 1 squared. So there's x plus 1 squared there, and there's another x plus 1. Don't repeat the other x plus 1 because x plus 1 can already divide x plus 1 squared. So your LCD will be this, which has a common with x plus 1, and the other factor that will make that the least common denominator. Least common denominator means what would be the expression that can be divided by both. All right? So x plus 1 squared times x minus 1 can be divided by x plus 1 times x minus 1. It can also be divided by x plus 1 squared. So that's your LCD, x plus 1 squared times x minus 1.
Can
Yes?
can the LCD also be x squared minus 1 times x plus 1?
Can be, yes. But we want the LCD to be factored because we want our final answer to be in factored form. Okay? Yeah,
So
you are
x squared
correct.
minus 1.
It is actually, it can also be x squared minus 1 times x plus 1. But in the end, we want the final answer to be factored form. So I suggest that you better just use yeah, because this one is the same as x squared minus 1 x plus 1. That's okay. They are the same. But this is a more preferred LCD.
Okay.
Okay. Thank you for that question. But they are actually also the same. So we'll use that as our LCD now, x plus 1 squared. Okay, I just want to rewrite the fractions. So actually, so this is the same as 1 over x plus 1 x minus 1 plus 2 over x plus 1 squared. Okay, so you can do number 2, but you can go directly if you wish to. Right? So what do we do? Yeah, so that this one will be x plus 1 squared times x minus 1. I should multiply 1 by x plus 1, right?
Plus,
Yeah, I need
yes.
another x plus 1 so that they are the same. For this, so that it will have this x plus 1 squared times x minus 1, I multiply this by x minus 1. Is that fine?
Yes.
Okay. So you'll now have 1, okay, 1 times, as far as this is concerned, that one, x plus 1, right? And then 2, so that I will have now x plus 1 squared times x minus 1. I will multiply this by x minus 1. Is that okay?
Yes.
Yeah. So it will now be x plus 1 plus 2x minus 2 x plus 1 squared times x minus 1. Final answer?
X minus 1 over
3x
x.
minus 1 over x plus 1 squared times x minus 1. You see, once you have the least common denominator, if once having that, then you just ask yourself, what will I multiply the numerator and the denominator such that you will get that least common denominator. Any question?
No.
I am. How come? Yeah, how I wish that in the screen I see all of you. Yeah, what's the problem there? Why or only 3 people can be seen, or I yeah, once in a
That's because you're
while I
sharing.
would see Abigail, once in a while I would see Rachel, but not always. Are they
I
situated
think that
somewhere else?
the camera points at you when you talk. So if I'm talking, it shows you me. But if somebody else is talking, then it shows you them.
Okay, so it points to the person talking. Okay.
Yeah.
Oh, I thought you were talking about snow. Yeah,
Can I okay, so when Abigail would speak, then I would see. Can Rachel speak so I could see?
Yes, I'm here. Okay.
Yeah, all
I know.
right. Thank you. Okay, so please just ask in for anyone so no, there's no question as far as this is concerned. Yeah, don't uh,
Yeah. For me, I have no questions.
No, don't.
Have any?
All good.
hmm.
Ooh, Curtis is
Yeah,
going
because
in.
like I anyway, we will try that whenever I would give a quiz, I will not give you a very difficult problem. Yeah, just so I would know whether you know the principles, okay? So don't worry. I will choose problems that are something that, very manageable and will not take also a long, long time to work on. So we're actually done with all polynomials. We have done uh simplifying by just adding like terms. You remember that? Then we learned how to multiply polynomials. Then we learned those special products kind of thing. And then we learned how to factor all of those factoring by factoring the expressions that have leading coefficient as 1, factoring by grouping, factoring difference of two squares, difference and sum of cubes, as well as perfect square trinomial. And then today we learned how to simplify rational expressions the last time, including now the multiplying, the dividing, the adding, and the subtracting. So we'll have a quiz on this on Tuesday. Right? So I have given you homework on factoring. So please just work on those. I will give you feedback as soon as I have already marked some, I think, Bethany is the ones who submitted, but I just want to give the feedback at the same time. So then that other homework on factoring. And of course, I won't give homework on this anymore. You just I suggest, look at your book. Then as I mentioned in the book, in the appendix, all those odd numbered items have answers. So it is just for you to practice how to add and subtract, how to divide, multiply, then practice on those. And so the coverage of our next quiz on Tuesday, the beginning of the class, maybe I'll give you, if ever, I tell you that it's already time and you still need more time and you would say, oh, I'm not done yet. Well, of course, we don't want to prolong too much. But if you need extra 5 minutes or so, just tell me so that I can extend a little bit, because I also don't want you to say, well, I did not work on it because I lack time. So we'll work on this together. So just tell me. And if we say, can we extend for another 5 minutes? Then that would be fine. So as I was already saying, if ever I solve the problems, I mean I prepare the exam, and then as if I would copy the problem and write the answers. And if I finish that in 15 minutes, then I would say, well, I think that would be good for you for an hour, something like that, to give you more time. So we'll try to see, and I'll see how much I will. I won't give too many. I will give one problem each, maybe. It's section, like simplifying, multiplying, uh, different polynomials, multiplying a binomial, all right, factoring. So, including adding, subtracting, multiplying, dividing rational expressions. So that's what we will be doing first part of our class on Tuesday. And I think that's what you prefer. You want the exam first before we proceed to the next. Actually, we are really very late on things, but I believe that the most important uh, concepts in algebra will be able to finish, not those complicated ones that will prepare you for calculus, because I think you are not required to take calculus. So we'll just look at those different topics, right? And if ever you have some questions that really need my attention, just send an email or just send a text message, and I will be prompt to respond to whatever questions you will have. So now I just want to, because as I was already saying, we're getting too late with our supposed to be, we are already in chapter 3 of our, now we are just beginning chapter 2. So I'll just proceed with introduction of your chapter 2, which would be equations and inequalities. And the introduction is just reminding you of what we call the Cartesian coordinate system, the graphing. I hope that this one is an interesting topic because you'll be doing some graphing. So you know that this graphing, this Cartesian coordinate system is a very powerful figure, all right, with your different quadrants. You know, you have the x-axis and the y-axis. And yeah, so we know what we have, what we call quadrant 1, quadrant 2, quadrant 3, quadrant 4. And of course, dealing with these are number lines. A number line, horizontal number line, and a vertical number line. And in the number line, you have points, or you have numbers there, infinite numbers, okay? Both in the x and the y axis. And so I think all of you learned before that the values, the signs of x to the right are positive. The signs of y as you go up is negative, are negative. The signs to the left are all negative, x, and the signs going down are all negative for the y. So we have the x and of course there we call this the origin. Okay, and a point on these quadrants are called ordered pairs. We'll have some examples in a little while. So if I put a point here, then that must be an ordered pair, which means a point along the x and a point along the y. Right. So that's a Cartesian coordinate system. All right, just for a while. I'm sorry. Let me first stop share because I want to put the sound. I forgot to share with the sound. Okay. All right. I'll share the sound because I just want us to be reminded.
I think it's better to be good.
We could look here, but then you can't.
Yeah, that's the problem.
That's the owl that you're looking there, so it looks like you're not paying attention when you
Okay.
are.
So, the Cartesian coordinate system has a very interesting history. And it says it's all started with a fly. And a man named Rene Descartes. Okay, so this man, Rene Descartes. So you're seeing, okay, you're seeing my screen. So let's listen to a little history of, so let me just play. Let me see if I can play. All right. Are you hearing the sound?
Philosopher, scientist, and
Yes.
mathematician Rene Descartes is widely considered one of the greatest figures in the development of modern science. One of his most enduring legacies is the Cartesian plane. The legend goes that one day Descartes was lying sick in his bed. Unable to sleep and with no internet to keep his mind occupied, he lay there for hours when he finally noticed something crawling around on the ceiling. As he studied the motions of a fly, Descartes experienced a sudden epiphany, a realization that ended up changing history forever. It occurred to him that at any given moment, he could describe the fly's exact location using only two numerical values. If one corner of the ceiling was used as a reference point, the origin, then the fly's location could be described by the horizontal distance from that point, followed by the vertical distance. These two numbers are the coordinates of the fly's position. This simple concept developed into the Cartesian coordinate system as we know it, named after Descartes himself. This, in turn, led to analytic geometry and the modern convention of representing unknown values in functions using x and y. These advances in mathematics provided a fertile basis for the development of calculus by Leibniz and Newton, independently of one another, just decades later. And now, even 4 centuries later, the Cartesian plane is such a foundational part of math and science, all because of the chance encounter between a brilliant scientist and a fly.
Okay. Let me. Yeah, just one. Okay, now. So isn't that interesting? Yeah, that
Mhm.
it's just because of a fly that Rene Descartes was able to look at, introduce this Cartesian coordinate system. Yeah, or some people would say it's the rectangular coordinate system. So yeah, many times I would say maybe you have already read. I told you to please read a little bit about that part one, this is part two of the article that I have posted on the history of mathematics and mathematicians. That I believe that this discoveries of these mathematicians, they are God's revelation, all right? Trying to help mankind to develop in their pursuit of wisdom and understanding. And so for Rene
Sure.
Descartes, God used a fly, and of course his intellect. For us, we see things. We don't even, we see a bee, and that would be fine. The bee would fly. But for him, while sick in bed, did not waste time to think of something that paved the way to analytic geometry. And actually, we are considering Rene Descartes as the founder or the father of analytic geometry. Analytic geometry, which is actually the combination of algebra and geometry. Yeah, it's a very, very nice branch of mathematics. And so this Cartesian plane is not only used in algebra, it is now used in everything, in statistics, and even definitely as we do some presentations of some of our results, of some of the graphs that we do, even in business and those kinds of things. Then we use what we call the Cartesian coordinate system. All right. So let's just now proceed. And um, that's what Cartesian coordinate system is all about and how it came about in life through a fly and Rene Descartes. Right. So it was mentioned in that video that, yeah, really any position that of a point in the coordinate system is an ordered pair. All right. It is now the distance from the origin to the x-axis and from the origin to the y. And so our coordinate system would be of the pattern xy. You begin with x as the first number and y as your second number. So if this point, as you move along, okay, then that is a 4, and then going up is a 2, and that for that point is a 4, 2 as a coordinate. Okay. Yes. So like here. All right. If I say which point is 4, -3. Where do I get that? Where is the point 4, -3? Okay. So you say 4, go to 4 to the right. If it's -3, go to the at the bottom. So in other words, okay, let me write that one. Okay. So the point for -3 will be go across to 4 and go down to -3. So this is now our point. All right? That will now be 4, -3. So if I have -6, +5, -6, 5. So what do? I go to the left, -6, and go up to 5. So I this way, -6 and move up to 5. And so that will be our point, right? So if I have -2, -7.
Go to the left 2 and down
Okay, so you
7.
go to the left -2 and go down to -7. Okay, now let's see. What are the coordinates of this point?
5, 5.
Okay, so that's everybody agrees that's 5, 5. Okay. How about this one? What are the coordinates of this point?
-7, 2.
-7, 2. Right. How about this point? That one.
-4, 0.
All right, that will be -4, 0 because you don't move up to the along the y-axis the y-axis. So how about this point?
Zero plus 5 or 0, 5.
Okay, it is now you didn't move to along the x, but you moved across the y. All right. How about this point?
-8, -6.
All right, -8, -6. So that's an important concept because when we do graphing, we need to deal with those different points along the coordinate system. All right, so that's how to plot the ordered pairs. So I think that one you are okay. Now, so we will be learning how to graph equations into variables. All right, so that is considered actually a linear equation. But anyway, so if I have an equation y is equal to 2x minus 1, that means that you have a dependent and an independent variable. We consider our x to be independent and y as dependent because the value of y depends upon the value of x. So the most elementary, I would say, the most elementary way of graphing equations is by looking for ordered pairs and then connect the points. So let me begin with that most elementary way just to remind us of how we are able to do graphing if I have the equation y is equal to 2x minus 1. So what we do is we usually, in most cases, I would use the -3, -2, -1, 0, 1, 2, 3 as the values of x that we would plot on that equation, y is equal to 2x minus 1, and then find the coordinates or the ordered pairs. So we are now saying, yeah, just for illustration here, if your x is -3, all right, just like what we did in our evaluating algebraic expressions previously, you substitute -3 instead of x, and then proceed with the multiplication with the process. So it's 2 minus 3 is -6 minus 1 is -7, so that your coordinate would be -3 -7. Yeah? If x is -2, 2 times -2 minus 1 is -5. So it will be -2 and -5. So we always begin with the x coordinate. If your x is -1, 2 times -1 minus 1 is -3. And so those are the coordinates. For 0, 2 times 0 is 0, minus 1 is -1. Those are the coordinates. X is 1, 2 times 1 minus 1 is 1. Coordinates are 1, 1. Okay, if x is 2, 2 times is 4, minus 1 is 3. So 2, 3. All right? And if your x is 3, 2 times 3 minus 1 is 5. So that will now be 6 minus 1 is 5. That's 3, 5. And then, after that, you now just proceed. We now plot all the points. So I now have -3 -7, -2 -5, -1 -3, -1. Okay, this one is 0 -1, 1 1, 2 3, 3 5. And then just connect with a straight line. In other words, these points would form a line. And this is the reason why we consider y equals to 2x minus 1 as an equation which is called linear equation, because this equation, when we graph, would form. Yes, so it's like just like that. Although, of course, we can plot the points without doing this, but just for the illustration, okay? So if I now have y is equal to minus x plus 2 for our okay, so let's do that. Okay, so y is equal to minus x plus 2. If x is -3, what will be the value of y? So that's
If x is -3 is 3
minus
plus
3
2,
plus 2. The value of y is
5.
5. All right? Okay, so the value of y is 5. Therefore, I'll have -3, 5 as our coordinates, right? -3, 5.
Oh.
-3 is 3 plus 2. What if y is equal to -2? What will be the coordinates?
If what?
-2, 4.
-2, 4. Good. All right. If the coordinate, if your x is -1,
-1, 3.
-1,
No.
3. Yeah, because it's
Oh, yeah.
-1 plus 2. So 1 plus 2, okay? If it's 0, coordinates are
2,
0, 2.
0, 2.
If x is 1,
It'd be 1,
1,
1.
1.
1,
Good. If x is 2,
2 minus 2.
okay, if x is 2, that will now be -2 plus 2. So therefore, what are the coordinates?
2, 0.
2, 0. Yes. Okay. If x is 3,
3 minus 1.
3, -1. All right. So those will be our coordinates. And so if we want to plot the points, yes, okay. Yeah, maybe you can do, yeah, so you need a graphing paper here, all right? So that you don't do a lot of lining there, okay? So let's try to, okay. So these were our coordinates that we already found: -3, 5, -2, 4, -1, 3, -0, 2, 1, 1, 2, 0, 3, -1. All right. And so minus 3, 5. So I move up to 5. All right, there, right? Minus 3, 5. Then minus 2, 4. Minus 1, 3. 0,
2.
2. It's there, right? Okay, that's 2. Anyway, maybe let's put that as a red so that it's easy for us to see. Okay. There. There. All right. Okay, and all right. There. Okay. And then 1, 1. And then 2, 0. It's there again. Mm-hmm. And then 3 minus 1. Okay, yes. All right, and then connect. Did I put the 2, 0? I am not very good in drawing a line. Okay. Especially with this, I need a ruler. Okay, so we just have to connect. All right. Anyway, it did not even. It should be that way. Okay. So it's now a line. That one is actually, it won't end there. It will be infinite. Yeah. So that line. It will go all the way. It will be a straight line. My line is not straight. Okay. All right. Now you notice that the line passed through the y-axis at this point, and it also passed through the x-axis at this point. Can you remember the terms for these points where the line passes through the x and passes through the y? Anybody who remembers your high school algebra?
An intersection?
Yeah, it's the point, like this point, 0, 2, and 2, 0. 0, 2, it passes through the y-axis. 2, 0, it passes through the x-axis. You remember the term? All right, so maybe,
No.
okay. Yeah, so that term, we call those intercept. Right?
Oh, yeah.
Yeah, so now it rings the bell, okay? So the x-intercept is the x-coordinate of the point where the graph passes or crosses the x-axis. And the y-intercept is the point where the graph crosses the y-axis. And actually, we don't need to do that very long way of plotting so many points. If we only know the x and the y axis, I mean the intercepts, x and the y intercepts, we already can graph the line. All right. So that's what we will be learning more. We can graph now the line, knowing the x and the y intercept. Right. Because you already know, if I go back here, if I know the x-intercept to be 2, 0, okay? And the y-intercept to be 0, 2, I can just connect this and extend the line without putting on all those different values, because it already gives you 2 points, because according to geometry, 2 points form a line, all right? Just connect 2 points, you get a line. So it's as easy as just looking for the x and the y intercept. And to do that, it's just easy. All right. What you do is to look for the x-intercept, let y be equal to 0 and solve for x. Now, we will now work on equations. All right. So 0 is equal to 2 minus 2x plus 4. And I think you know what to do. Okay, we cross, that 4 should cross that line. If it crosses, it will change to negative, all right? So it now have minus 2x equals minus 4. Divide minus 4 by minus 2 and minus 2 by minus 2, you get x is equal to 2. So the point is 2, 0. To look for the y-intercept, put x equal to 0. So 2 times 0 is 0. 0 plus 4 is 4. So what you do is just, all right, go up. If ever it so happened that it is not, this is 0, 4. But anyway, you go across to 2. Go across to 4. Get that point, and draw a line. And that is now our x and y intercept. And that's what we will be learning, how to graph using intercept. Well, of course, you have graphing calculators. That's not necessary. I won't require you to buy a graphing calculator. This is not a real calculus. So we will just be learning a little bit of how to do graphing. So next meeting, after our quiz on polynomials, then we will proceed with our a Cartesian plane and move on to the concept of equations and inequalities. So that will now be all for today, and I hope you have a good day. Yeah, we will see each other on. I will pray for you before I believe, so that I can lift you up to the Lord. Okay, especially that you will be preparing for the quiz. Let's bow our heads. Loving Heavenly Father, we thank you so much for today. Thank you for what we have learned so far. I lift up to you these students as they go for lunch and their afternoon activities. Kindly be with them. Bless them as they continue to work on the assignments that they have given and as they prepare for the quiz this coming Tuesday. Be our guide. Help us to trust you. Thank you for hearing us, for we pray this in Jesus' name. Amen. Okay.
Amen.
So God bless you
Thank
all.
you.
Have a great day.
See
Okay.
I
Bye.
think the quiz will be
on Tuesday.
Bye.
Bye.